Hemoglobin is a tetramer where the four subunits are separated from one another by a protein chain. Four polypeptide chains are present which separate these subunits. So the globin part, we call it as a protein part, which protects the four subunits from interacting with one another. What happens if the globin chain is absent is the question. Now in the absence of globin chain, the subunits interact with one another. Altogether there are four subunits, 2 alpha and 2 beta subunits. These subunits interact with one another and finally they form hematin. Hematin is also called as MetHemoglobin. Once the hemoglobin is converted into hematin, the hemoglobin will lose its reversible oxygen binding capacity. So how exactly does it happen? We'll try to see. In the first case, iron 2, which is present in the high spin state, will bind to the dioxygen where the iron is converted into iron present in +3 oxidation state with a low spin, and dioxygen is converted into a superoxo form. The first complex we call it as a superoxo complex. This superoxo complex, when the globin chain is absent, it may interact with the iron of another subunit. So this will lead to the Peroxo complex. Both irons are getting converted into iron 3+ state and the dioxygen is finally converting into a peroxo form. So this is referred as a peroxo complex. This peroxo complex will undergo cleavage and it will lead to the formation of iron 4. This is called as a ferryl complex. This is a ferryl complex. Such a ferryl, iron 4, will react with another iron which is present in +2 oxidation state. That would lead to what we call it as a hematin or MetHemoglobin. The another name given for this hematin or MetHemoglobin is hemaglobin. Not hemoglobin, it is hemaglobin, or we also refer it to as hematin or MetHemoglobin. If at all the globin is absent, then one iron subunit can react with another iron subunit. That may finally lead to the formation of hematin, where the oxygen is permanently bound between the two irons and hemoglobin will lose its reversible oxygen binding capacity. The same four reactions are being given as a cycle. Iron 2 reacting with dioxygen giving a superoxo complex, later on giving a peroxo complex, a ferryl complex, and finally it is leading to the formation of hemoglobin, hematin or MetHemoglobin. Now even in the presence of globin chain, regularly about 2 to 3% of the hemoglobin converts into hematin, but such a hematin is back converted into hemoglobin by an enzyme called as diaphorase. If at all diaphorase is absent, then the newborn babies may die due to the conversion of hemoglobin into hemoglobin. This can be seen in blue fugates. In blue fugates, diaphorase enzyme is absent. So in such a case, methylene blue is administered for such humans. Whatever activity that the diaphorase does, a similar activity is also done by the methylene blue. Diaphorase is also called as MetHemoglobin reductase, which can back convert the hematin or the hemoglobin into hemoglobin. Well, about hemoglobin, we have seen different forms: deoxyhemoglobin, oxyhemoglobin, geometric, magnetic and electronic aspects, the number of subunits that are present in it, process of cooperativity. Let us now come to myoglobin. Myoglobin is a monomer. There is only one unit in it, but it is attached to 153 amino acids. Molecular weight is nearly about 1/4 that of hemoglobin. It is 17,000 Dalton or 17 kilodalton. Myoglobin, since it is only one unit, we cannot have a process such as cooperativity. There is also no Bohr's effect. What is Bohr effect in the sense? In hemoglobin we have seen that the oxyhemoglobin, when it goes to the tissue or the cellular level, it gives away the oxygen, whereas it takes up the carbon dioxide in the form of carbonic acid or 10% carbon dioxide can also attach to the hemoglobin. But this giving away of dioxygen will happen in the presence of carbonic acid environment or when the pH will drop. So such an effect where the hemoglobin loses its reversible oxygen binding capacity in the presence of lower pH levels is called as Bohr effect. This was given by Christian Bohr, who was the father of Niels Bohr. In myoglobin there is no such process of Bohr effect. This is simply because myoglobin is a storage protein, it is not a transport protein. It will simply stay at the tissue or the cellular level. Hill's constant is found to be 1. It has 100% saturation levels and hence it is acting as a storage protein. Remaining all other aspects are similar to hemoglobin. All other aspects in the sense the geometric aspects or the magnetic and the electronic aspects are simply similar to that of the hemoglobin. Right. This is about the oxygen binding protein hemoglobin and its monomer myoglobin.